In this video, I'm going to solve this problem, and the problem says that you have 70,000 to invest and you have done some security analysis and generated the following data for two stocks and treasury bill. And average return of each security is given, stock A, stock B, and T-bill, and variance of each security is also given, and covariance with stock A is also given, meaning the covariance between stock A and stock B is 0.001 and covariance between stock A and T-bill is 0. And remember, the covariance between stock A and T-bill is 0, meaning T-bill and stock A are not related, and that is true by definition because T-bills are not correlated with any of the risky security, and variance of the T-bills also is 0. That is also true by definition. So given this information, what this question asks us to find out: first, what is the weight of stock A in the optimal risky portfolio? Second question is, what is the expected return of optimal risky portfolio? Third question is, what is the standard deviation of optimal risky portfolio? And finally, the final question is, if you invest 50% of your fund in T-bill and the rest in the optimal portfolio, what is the expected return of this complete portfolio? In a way, this question is asking information related to optimal risky portfolio, and we should know what optimal risky portfolio is, right? And optimal risky portfolio is the portfolio that has the maximum Sharpe ratio. So what we have to do in this problem is we have to compute the Sharpe ratio first, and once we compute Sharpe ratio, we can use Excel solver function to find out the maximum Sharpe ratio. And whatever solution we get after using Excel solver function, that solution will be related to optimal risky portfolio. So let's do it. And we have to compute here the Sharpe ratio, right? In order to compute Sharpe ratio, we need the portfolio average return and portfolio standard deviation. To compute the portfolio mean and the standard deviation, we need the proportion of money we put on each stock, right? So you can start with any proportion, but I'm going to do here 50-50%. So it's going to be 0.5 on stock A and 0.5 on stock B. And I need one more information later when we use Excel's solver function. So sum of the weight has to be 1, and I'm gonna do here equals to sum of the weight right here should be equals to 1. I'm doing this because I need this information later when I use Excel solver function. Now we can compute portfolio mean, portfolio standard deviation, and Sharpe ratio. So as we know, portfolio mean, right, the formula is given here, is equals to proportion of money you put on stock A times average of stock A, right, plus proportion of money you put on stock B times the average of stock B. So that gives us the portfolio mean. If you want to see the formula, I can do that. Formula text, right? Formula text gives us the formula right here, and I can drag it later so that I don't have to type again. Now we can compute the portfolio variance, and I have also given the formula to compute the portfolio variance here, and I've done this many times, so you can do it. Equals to the square of the proportion of the money you put on stock A times the variance of stock A, right, plus square of the proportion of money you put on stock B times the variance of B, right, plus 2 times proportion of money you put on stock A times proportion of money you put on stock B times the covariance between stock A and B, which is given right here, 0.001. So that gives us the portfolio variance, and once we have the portfolio variance, we can find the square root to get the portfolio standard deviation. So I'm doing here square root of the portfolio variance, and that gives us the portfolio standard deviation. Once we have all that information, we can compute the Sharpe ratio. Look at the formula right here. Sharpe ratio equals to the average return of the portfolio, which is 0.08, minus the risk-free rate. And the risk-free rate is given here. The average return of this T-bill is considered risk-free rate here in this problem. So I can say here 0.02 is our risk-free rate over the standard deviation of the portfolio, right? So I can do this right here. So that gives me the Sharpe ratio, which is 0.47. Now what I can do is I can use Excel solver function and find out the maximum Sharpe ratio, and whatever result we get, that belongs to optimal risky portfolio. So therefore let's go to data and click on solver, and now you have to make some selection. First, objective, you want to maximize or minimize? We want to maximize. What do you maximize? We want to maximize the Sharpe ratio, right? So you click on that right here. And what do you want to change? We have to select the changing cells. So here in this case we want to change the portfolio weight, right? That's right here. And finally we need to add the constraint. That constraint in this typical case is always going to be sum of the portfolio weight should always be equals to 1. That is our constraint. And there is another constraint if you want to choose whether you want to make the portfolio weights negative or not. So here's a tick mark here. If you want your portfolio weights to be negative, you can untick it, but I'm going to leave this as is. And once you make all this selection, you can click on solver and OK. Now it solved the problem. Now our portfolio Sharpe ratio is 0.51. Earlier it was 0.47. So that is the optimal Sharpe ratio, meaning the maximum Sharpe ratio. So in order to generate this maximum Sharpe ratio, the portfolio weight right now is 0.76 on stock A and 0.238 on stock B. So these are the portfolio weight associated with the optimal risky portfolio, and whatever resulting portfolio mean is calculated, that is the optimal portfolio mean, and whatever standard deviation you have computed, and that is the optimal portfolio standard deviation. So in a way, result gives you answer to all of this question. Now what is the weight of stock A? It is 0.76, right? That's the answer. Second question is, what is the expected return of optimal risky portfolio, which is 0.10089. And next question is, what is the standard deviation of risky portfolio, which is 0.15754, right? So that is given. Now finally it is also asking expected return of the complete portfolio if you invest 50% in the T-bill and the rest in the optimal risky portfolio. In this case, what you can do is equals to, so 50% you have invested on the T-bill, therefore 50% times the average return of T-bill, which is 0.02, plus the remaining 50%, which is 50%, right, times the average return of risky portfolio, which is 0.10089. So that gives us the average or expected return of complete portfolio, and I can show you the formula right here, the formula, and this is how you can do this problem. All right, thank you.